All right, so for our second section from Module 2, we're going to talk about parallelograms. And actually, for the next few sections of Module 2, we're going to focus on quadrilaterals or some different types of four-sided figures. So let's start with that concept. Number one, what I just said, the definition of the word quadrilateral, prefix quad means four. So quadrilateral is a polygon with four sides. Now, when you first think of a four-sided polygon, probably the very first thing you think of is a square, and the very second thing you think of is a rectangle. And those really are very common quadrilaterals, but not every quadrilateral is a square or a rectangle. There are a lot of other shapes too. So for example, for today, we're going to study a quadrilateral called a parallelogram. Now, the definition of a parallelogram is, number one, it's a quadrilateral, what we're talking about, and number two, both pairs of opposite sides are parallel. So maybe you have a top and a bottom that are parallel, and you have a left side and a right side that are parallel. Now again, when I say that, you're probably thinking of a square and a rectangle. A rectangle that describes a rectangle. Top and bottom are parallel, sides are parallel. But here's what could be different. You could have what's kind of like a rectangle tipped over to the side. So right now on your screen, you see parallelogram ABCD. Now this is the symbol for parallelogram. It's a little parallelogram, just like a little triangle is the symbol for triangle. Now, just like we use three letters, you might say triangle ABC. Well, a parallelogram has four vertices, so you call it parallelogram ABCD. Now, what you notice is exactly what I described. The left and the right sides are parallel because they have one arrow on them. The top and the bottom are parallel because they have two arrows on them. But it's not a rectangle. It's kind of like tipped over to the side a little. All right, now, because we're talking about two sets of parallel lines, all those theorems we learned from the first book, from the Math 1 book in Module 12, about parallel lines and transversals are going to be very helpful for parallelograms. So you want to remember your things like corresponding angles, alternate interior angles, which is the one I typed in for the notes. There was also alternate exterior angles, there was corresponding angles. Those theorems are going to be very helpful for you because we have parallel lines. So here's our theorems that we want to know about a parallelogram. And what I'm going to do, there's actually four of them. So instead of like doing one slide for each one of you and giving like a big paragraph to copy down, I'm going to summarize all four together, and then I'll give you an example of all four. So first theorem says, in a quadrilateral, opposite sides are congruent. And remember, I'm kind of summarizing it for you. What it really says is like, if polygon ABCD is a quadrilateral, then the opposite sides are congruent, or however you want to word it. I'm going to summarize. So in a quadrilateral, opposite sides are congruent. We already knew they're parallel because that's the definition of a parallelogram, but they're also congruent. Number two, opposite angles are also congruent. Number three, the angles that are not opposite each other and therefore congruent always add up to 180. They're supplementary. And finally, number four, if you draw in the diagonals of a parallelogram, if you connect the two opposite corners, then those lines bisect each other. They cut each other exactly in half. So those are our four theorems. Let's take each one of them and apply it to a picture. Okay, so we have another parallelogram. It's ABCD again. This time I drew the diagonals in. I connected from B to D, that's one diagonal. I connected from A to C, that's another diagonal. And then the point where they meet, I called it point E. So we had four different theorems. Let's apply each one to this picture. The first theorem, I said opposite sides are congruent. So that means AB is congruent to DC, the top and the bottom. And it also means BC is congruent to AD, the left and the right. Okay, the second theorem said opposite angles are congruent. Now that means angle DAB, which is this corner here, is congruent to angle DCB, which is this corner down here. It also means angle ABC, which is this one up here, is congruent to angle ADC, which is this one down here. So the opposite corners are congruent. Number 3, I can't really mark on the picture, but basically what it says is if you take any two of the angles that are not congruent, they add up to 180. So like this one here and this one here add up to 180. Or this one here and this one here add up to 180. Any two, if you pick one of each group, one out of A and C and one out of B and D, then you add them up, they're going to add up to 180. Now the final theorem was about the diagonals bisecting each other. So our last theorem says AE is congruent to EC. If the diagonals bisect each other, that's cut in half. And DE, I'm going to use 1, 2, 3, 4 markers here, is congruent to EB. 1, 2, 3, 4. So you can see there's a lot of things in this picture that are congruent. There's a couple things that are supplementary that add up to 180, but there's definitely a lot that are congruent. So let's take some of these theorems and turn them into examples. So for this picture right here, I want to find all the missing sides and angles. So I gave you two sides and one angle. I said side AB is 12, side AD is 15, and angle C up there is 75 degrees. Now what I'm going to do for my answer, I think I'm just going to fill it in the picture. Let's go through our 4 theorems in order. The first theorem said opposite sides are congruent. So if AB is 12, so is CD. And if AD is 15, so is BC. Okay, second theorem said opposite angles are congruent. So if angle C is 75 degrees, so is angle A. And let me take this opportunity to give you guys a quick notation reminder. If I'm talking about an angle, I can call it angle A. If I want to give a degree measure for it, I put the M in front of it to mean measure of angle A. Just like if I'm talking about a line segment, if I wanted to talk about a line segment being congruent, I might say line segment CD. But over here, where I didn't put the line segment on it, that's like saying measure of. So if I say CD with no line on it, that's talking about how long it is. And that was something from book 1, just another quick notation review for you guys. All right, so I said find all missing sides and angles. The only thing I need is angle B and angle D. And I know they're equal, they're congruent. And the way I'm going to find them is I know that they have to add up to 180 with the other one. So basically, if I just very quickly go off to the side here and do 180 minus 75, I get 105. That's both angle B and D. These are both 105 because they both have to be equal and they both have to add up to 180 with the other angle from the picture. And that'll be my last two answers. I'm going to say measure of angle B is 105 and measure of angle D is 105. So you could have just wrote it on the picture and that would have been fine for an answer, but I also made this list over here for my final answer. Okay, so we used our theorems to find any missing sides and angles. We labeled everything. The one thing that I didn't do in this picture was our 4th theorem about diagonals. So let's do one last example for today. Oh, actually, you know what? I have 2 more examples. Let's do this one and then we'll come back to diagonals. So let's do a solve for x question. I gave you a parallelogram. You can tell it's a parallelogram because of the arrows. Both sides are marked parallel. And I gave you 2 of the angles, 3x minus 15 and 2x plus 10. Now, I talked to you guys about this in class. I said, here's the common mistake. I'm going to show you the wrong way to do this question. Without even thinking about it, people look at the picture, they say, I have a 3x minus 15, I have a 2x plus 10, so I'm going to say 3x minus 15 equals 2x plus 10, and I'm going to solve for x. Now, that's wrong, because those angles are not equal. You can tell just by looking at them. Angle A is acute, it's very small. Angle B is obtuse, it's very big. So this is wrong. And I told you guys in class, don't get in the habit of just like automatically saying, oh, I see two things in the picture, so this one equals that one. The key to this problem is to really think about your theorems and the relationship between what's in the question. Now, the relationship between these two angles here is they add up to 180. So when I'm setting up my equation, it's not going to be 3x minus 15 equals 2x plus 10. It's going to be 3x minus 15 plus 2x plus 10, add them up together, and they equal 180. That's the equation you want to solve. So let's go ahead and solve that equation now. Start by combining like terms. 3x plus 2x is 5x. Negative 15 plus 10 is negative 5. So right now I have 5x minus 5 equals 180. And then we'll finish solving. So I will cancel out the 5 next. I'm going to add 5 to both sides. And I get 5x equals 185. We'll divide both sides by 5 to cancel out the x, or the 5 in front of the x. And that'll be our final answer. It's going to be 37. So x equals 37, and I went ahead and boxed it up. The other thing I always remind you about in this type of question is once you think you're done, before you move on to the question, go back and look at what I asked you. I asked you to solve for x, so we're done. X is 37. I could have said find angle B, and then you would have had to plug in 37 to figure out what it is, or find angle A, or something like that. But the big thing is, don't set them equal. Those two expressions were not equal in this picture. They're supplementary, which means they add up to 180. All right, so here is our last example for today. This is the one I was thinking of a second ago, where we're going to actually use the diagonals here. So I said solve for each variable in the parallelogram. So there's two variables in here. We have a w and a z. Now, our last theorem was, because it's a parallelogram, and it says right in the directions, it's a parallelogram. I didn't put the little arrows on this time, but that's another way I can tell you it's a parallelogram. I said once you know it's a parallelogram, you know the diagonals bisect each other. So this piece is congruent to this piece, and this piece is congruent to this piece. What that means is two things. This one is equal to this one. That's my first equation. And this one is equal to this one. Now, if we solve each one of these, that's our answers. We found the variables. So let's just do them one at a time. Start over here. I have w's on both sides. Let's get rid of this one. I'm going to do a minus w on both sides to cancel the one on the right. 3w minus 1w is 2w. 2w equals 8. Divide both sides by 2, and we got the first half of our answer. W is 4. Now I asked you to solve for each variable, so let's do z next. Same concept, I have z's on both sides. Let's get rid of the smaller one. Actually, you know what? Let's get rid of the 4z this time. Because if I get rid of the smaller one, I have nothing on that side. So this is one of those times I usually get rid of the smaller variable, but since there's nothing over there with the 2z, I'm going to get rid of the 4z. And I'm going to have negative 9 equals, now 2 minus 4 is negative 2z. And then to finish solving for z, I'm going to divide both sides by negative 2, cancel that negative 2 out. And what I get for z, negative divided by negative is positive. 9 divided by 2 doesn't go evenly, so you can leave it as a fraction, 9.2, or you could put it as a decimal, 4.5. Either answer is fine, but it definitely is positive. Negative divided by negative is positive. And now we saw how all four theorems can be used.